Now let's look at the next topic, multithreading. What do you mean by multithreading? Multithreading basically means a lightweight process. Threads are lightweight processes. Threads are separate paths of execution which are functionally independent of each other. Now, how are threads different from multiprocessing or even multitasking? Because in case of multiprocessing, what happens is, it is many user processes which are being processed by a single processor. Multitasking is single user many processes being processed by a single processor. So if you look at, for example, Unix system or novel NetWare systems, you have any commands that you specify goes to, in a Unix system, to the server processor, gets executed there. So if we are talking about 10 users working on a Unix system, all 10 user processes get executed in the server processor. Unix system is also multitasking. So how do you say multitask? How would you define a multitasking then? As we said, a single user, multiple processes is multitasking. As a single user of a Unix system, as one of the users of a Unix system, you can issue more than one process command. You can have one foreground command and rest background commands. So each of those processes are still executed at the server. But as a single user, you are executing more than one process. So that becomes multitasking. Similarly with your Windows platform. You open to a notepad, open to a calculator, you open to your email box. You are working with more than one application at a time, more than one process at a time. So that becomes multitasking, single user, many processes. Multithreading is single process, within that single process you have paths of execution. That is multithreading. Within a single process, you have multiple paths of execution is multithreading. For example, you open a Word document. In the Word document, you will type in the Word document, and at the same time while you are typing in, autosave gets executed parallelly. Spell checker gets executed parallelly. I mean, it looks parallel to us, right? At the same time. How is all these three things happening at the same time? Because it's multi-threaded. Sometimes you might also have noticed, you might have opened to multiple browser windows, probably by saying new window through links. If you were to close the first window that you had opened, you will see that all the rest of the windows will also get closed. You might have observed this sometime. So that's again multi-threaded. In case of multi-thread, if you were to check out your processes which are running, you'd only see one process running. For the threads, you don't see the process. So there is no process ID as such. So they are lightweight processes. If the main application were to close, the threads do not exist. Imagine closing your Word window. Will your document, spell checker and your autosave be running? No. So in case of multiprocessing and multitasking, each process has a process ID. It has its own memory space to work with. In case of multithreading, since it is a single process within which you have multiple paths of execution, for a threaded application, it is all the threads share the same resource that has been allocated for the application. So the same memory space is shared by all the threads in case of a multi-threaded program that has been allocated for the application. That's the difference between multiprocessing, multitasking and multi-threading. Now threads have their own life cycle, they have their own properties. There are different types of threads that you can create. There are various ways of creating threads. Let's look at all these applications. A thread life cycle starts with the ready state. From a ready state, it moves into a running state. From a running state, it can move into a sleep state or to a death of a thread. To move from ready state to a running state, first let's understand when is it in a ready state. When you create a thread, it's in a ready state. To move from a ready state to a running state, we invoke the start method. Start method in turn calls for a run method. So then it comes into a running state. From a running state, it can go to a sleep state in 3 different ways, or a wait state, whatever you want to refer it as, in 3 different ways. That is using sleep method, which takes milliseconds as parameter, using suspend method, or using the wait method. If we use a sleep method to put a thread into a sleep state, the thread will be in a sleep state till the specified number of milliseconds, after which it will automatically come back into a running state. If you call suspend to bring back from a sleep state to a running state, we need to call resume. If you call wait, then you need to call notify or notify all. To move from a running state to a death of a thread, you come out of the run method, which the start has invoked, or call stop on the thread. It is the run method where the entire execution of the thread is defined. Our entire functionality of the thread is defined in the run method. So when you come out of the run method, it's the end of the thread. Since JDK 1.2, the stop, suspend and resume methods have been deprecated. It means to say that you should no longer use these methods. You just get a warning if you were to use it. It's not an error. So you should not be making use of these methods ideally. The reason why these have been deprecated is, imagine your thread is running, one thread is running, another thread calls stop on this thread. You have thread 1, thread 2. Thread 2 calls stop on thread 1 when thread 1 is working with some resource. So it abruptly comes out of execution, leaving the resources, which can damage the data or corrupt the data. So if at all you want to come out of execution, come out with the proper conditions. You should not be therefore using a stop method. That's why it's been deprecated. Similarly with suspend, if you invoke on a thread, till resume is called, you're not going to come back. So till then, you're holding the thread state. Okay? So that can end up getting into a loop, in a sense that you will never end your program totally, and other threads could end up waiting. We'll look more into why this is so little later when we discuss about synchronization. You'll understand better with that. So this is the life cycle of a thread. The wait and the notify methods we will discuss later again.